Okay, this video is going to cover lesson 6.5, which is called linear inequalities. Okay, so what we're going to look at is how do we graph something on an XY axis that has an inequality symbol in it. So how would we graph things like this? Okay, we've already learned how to graph a line. We've also, back in chapter 3, started talking about less than, greater than, less than, equal to, greater than, equal to, but it was just on a number line. There wasn't two number lines. There was just the one axis, okay? So we're going to look at, okay, now what happens when we have the XY axis and how do we graph that? Okay, so to get started here, it says determine whether the ordered pair is a solution of the linear inequality. Okay, now the easiest way to do this is just to plug in and see if it works or not. So I know that this is my X value and this is my Y value. So I'm going to plug X into my X position and Y into my Y position, and we're going to find out is the inequality true or false. So I'm going to have 2 greater than 1 minus 3. So now, is 2 greater than, when I take 1 minus 3, I get negative 2. So is that true or false? Well, alligator is definitely eating the bigger number here. So since the alligator is eating the bigger number, that's a true statement. So if it's a true statement, or if it works, yes, this is a solution. Okay. All right, so now we're going to do the same thing again, but we're going to do it with negative 3, negative 7. So I'm going to go ahead and plug in my Y value. Negative 7 greater than, my X value is negative 3 minus 3. Okay, so again, just to kind of clarify, I just plugged X into the X position and Y into the Y position, and now I'm going to see if it's true or false. Okay, so I zoom back in here, and I'm going to get negative 7 still on this side, greater than, negative 3 and negative 3 is negative 6. So now in this case, is the alligator eating the bigger number? No, he is not. This is not a true statement. Guys, keep in mind that when you've got a negative, right, you got to kind of think backwards, okay? So alligator should be eating this negative 6, not the negative 7. So is this a solution? No, it is not. Okay, going down to the next one. So we're going to start by graphing these. Now we're going to graph them just like we were graphing a line. Keep in mind that this would be the same thing as y is less than 0x plus 4. All right, so you're still doing kind of the same stuff. Here's your start position at 4. All right, so I'm starting at 4. Now a slope of 0 would be a horizontal line across. Now here's what we got to be careful with though. Just like when we were graphing these on a number line, open circles and closed circles were different things, okay? So if you have less than or greater than, you're going to put a dotted line, okay? And that means it is not part of the solution. Okay, so dotted line, not part of the solution, so there's kind of your first point there. Okay, the second point that we're going to put here is if it has an equal sign on it. So if it's less than or equal to greater than or equal to, it's going to be a solid line. Okay, and that means part of the solution. Close that off. Okay, so it's kind of the same thing. Remember, we used to have like an open circle here and a closed circle. It's the same concept there, but now we're going to have a dotted line and a solid line. All right, so if I come back over here and look at this, because I have a less than symbol, I am going to have a dotted line horizontal, right, because my slope is 0. So I'm going to have a dotted line across. Now, the second part to this that's a little different than just graphing a line is that we've got a shade. Okay, there's going to be a lot of correct answers here because all numbers that are less than 4 will work. Okay, so think about that. If y is less than, where would less than go? Well, less than would be everything down, right? Down. So what numbers are less than 4? Well, 3, 2, 1, 0, negative 1, negative 2. All of these would work. So we're going to shade. And when we shade, we've got to shade the whole side, just nice and light there with your pencil. So go ahead and shade that whole entire side there. Okay, and so what this means is anything in this shaded region here is an answer. Yeah, that's going to work. Anything, if I look on this line, though, because it's dotted, that is not going to work because it's not part of the solution, right? The word not part of the solution. And then if I even go up into the white region here, that's not going to work either because that's not where the shading is. So wherever the shading is where your answers are, okay? All right, so let's try this again. Let's actually drop down and we're going to look at this guy next, and we'll come back up in just a minute. All right, so let's go ahead and start with our graphing here. So I'm going to start at -3 on my y-axis, right, because that's my b value. Okay, now I actually have a slope here, and I need you to be thinking about rise over run. Okay, so since it's negative, right, -1, that means I'm going to go down 1, right 2. Down 1, right 2. I'm going to go ahead and put a point there. And then I'm going to go ahead and just put some points up in the other direction there just to help with my line. Now, again, there's no equal sign on this, right? It's just less than. And since it's less than, it's going to be a dotted line. Arrows on the end. Okay, so now when I look at this, this is saying less than. So what I want you to think of is, okay, here is your starting point right here. Start point. Okay? If it would be greater, you would shade everything on the high side. If it is less, from your start point, you're going to go down. Everything less than that start position. So I'm going to shade everything here on my low side. Okay, so everything on that low side, less than, go below. Okay, so again, everything in this region is an answer. On the dotted line would be not an answer, right? Because it's dotted, it's not part of the solution, and everything up here is not an answer. So the only thing that works is everything in this green shaded area. All right, we're going to go ahead and slide across now and look at this fourth example here, and then we'll go back up. Okay, so on this guy, we've got to make sure that we solve for a y, right? We've got to isolate that y. Okay, so to isolate that y, I'm going to start by subtracting that 4x over to the other side. So I get -3y is less than -4x plus 6, and then you're going to divide everything by -3 to isolate that y. Now, just like when we did inequalities back in chapter 3, when you divide or multiply by a negative, remember that inequality symbol has to change directions. So it's actually going to be y greater than 4/3 x minus 2. Okay, so now I'm going to start at -2 on my y-axis. I've got a slope of 4/3, so I'm going to go up 4 and then right 3. Okay, again, no equal sign, so it's going to be a dotted line. Okay. And we're going to be looking at this guy. So we always focus in on this guy right here as far as shading and what all we do. Okay. So whatever that guy says is what we're going to look at. So this case, it's greater. So greater from my start position, right? My start position, greater would go up. So I'm going to shade everything on the high side here. Okay, because greater goes up. Okay, so nice, lightly shade everything on that side. Okay, and again, all of your answers would be in this yellow area. Nothing on this line will work because it's dotted, and nothing over here will work because it's not shaded. So the only thing that works is everything in the yellow area. All right, so now let's go up real quick because this is our special guy, right? X is greater than or equal to 1. He's always our special guy. So we're going to look at, right, he's starting on the x-axis at 1. He's got an undefined slope, which means it's going to be a vertical line up and down. And because I have an equal sign here, I'm going to make this line solid. So I'm going to have a solid line that's vertical, crossing at x equals 1, or crossing at 1 on that x-axis. Now again, because he's special, guess what? This is special too. It's not up and down, okay? So everything we did here, right, was if it was less than goes down, less than goes down, greater than goes up. Here there's no down or up, it's either left or right. So just like when we were graphing back in chapter 3, you just looked at the direction of your arrow, right? You're going to do the same thing here. Which way is this arrow pointing? And if you have to, go ahead and make a little sign, make an arrow. All right, so if I'm looking there, right, my arrow's pointing that way. So that's the direction I'm going to shade. So everything to the right here is going to get shaded. Okay, so anytime we've got something with that x equals, that's our special guy. Okay, so now if I'm thinking about coordinate points that would work, anything in this red region would work. Anything on the solid line will now work, right? So these guys are both good. However, if I go over here and put a point over here, that is no good because it's not in the shaded region. Okay, let's go to page 2. All right, so now on page 2, what they're asking you to do is to write an inequality of the graph. All right, so this is where we got to write an equation kind of our line first. All right, so we're going to need to identify what our slope is, and what our b value is first before we can do anything. All right, so let's see, b, where's it starting? Well, it looks like it's starting at 1, so there's my b value. Now again, find a pattern, right? Find a pattern for that slope. Where does it look like it's crossing? And then do rise over run. So I'm rising 2 and running 1. So 2 over 1 or 2, right? Rise over run. Okay, so now I've got the start of my inequality here. I've got y. I'm going to wait for a second on that sign. And then mx plus b would be 2x plus 1. Okay, now the first thing I look at here is it's a solid line. So if it's a solid line, it should have an equal sign on it. Okay, now which direction are they shading? Well, in this case, it's the yellow area. So the yellow is your shading. So if I look at that, think about that. That's going down. So if that's going down, it should be less than. Less than. All right, let's try this again. Okay, so again, what's your m value? And what is your b value? All right, well, it looks like I'm starting at -3. And then my slope, man, it looks like it's maybe going to cross up here again. That one's a little bit trickier. So I'm going to do rise. So I'm rising 3, and I'm running 2. So rise over run, or 3/2. So again, now I'm going to start my equation. Y equals mx plus b. So 3/2 x minus 3. And now when I look at this from my start position, where's the shading? Well, all of the shading's going up. So that means that I should have greater than the dotted line here. It's dotted, so there's no equal sign on that. So it's just greater than because it goes up. And that's my answer. All right, last question here today. It says, define a variable, write an inequality graph, then name a solution and interpret its meaning, the meaning. A yearbook company promises to give the junior class a picnic if they sell at least $28,000 for yearbooks and class rings. Each yearbook costs $35. Class rings are $140. How many yearbooks and class rings must the junior class buy to get their picnic? All right, so notice here, they're asking us to find two things. They're asking for how many yearbooks, and then they want to know how many class rings. Okay, now, if I have to graph, I'm going to go ahead and just leave it as X and Y's to make it easier for graphing. Now, if you want to use like C for class ring or whatever, you can do that. That's fine. But it makes graphing easier if you kind of leave it in terms of X and Y. So what I'm going to do here is I'm going to make X my yearbook since it's the first one there. So X will be number of, I'm just going to put YB for yearbooks. And Y is going to be number of, and I'm going to put CR for class rings. Okay. All right. So now when we look at this, we know that we need at least $28,000. So there's your total, right? $28,000 is your total. Okay. Now, what do we know about yearbooks and class rings? Well, we know that yearbooks, right? If I look here, yearbooks cost $35. So I'm going to put 35x plus, all right, now do your class rings. Class rings are 140. Y. Okay, now let's think about that word at least, right? If I have at least 28, would we be okay going over 28? And the answer is yes. So at least 28 is your smallest, which means alligator eats the bigger side. Now at least means you could get exactly that, and that would be okay. Okay. Now, when you guys are graphing this, I recommend the cover and divide method. I recommend you find intercepts. Okay. So remember how we would like cover this up and then divide by 35 and cover this up and divide by 140. So we're going to find those intercepts. Okay. All right, so if I'm looking at this, let's find the x-intercept first. So technically I'm covering this up. So I'm going to have 35x greater than or equal to 28,000. All right, so now I'm going to divide 28 by 35. And I end up with 800. So I end up with 800 for my x-intercept. Okay, now I'm going to do my y-intercept. So I'm going to come back up here real quick to the top. And I'm going to erase this. Oh, I was hoping it would erase. We'll just put 140 back in there. Okay, now this time I'm going to cover this guy up, right? Cover up. And so now I'm going to divide by 140. So I have 140y greater than or equal to 28,000. So now when I take 28,000 and divide by 140, I end up with 200. All right. Okay, so now 800 on my x, so I need to get out to 800. So I'm just going to count by 100s. Okay, so kind of zoom in here. Now remember, this is always 0. Oops, not my pen. So I get 0 here, and then this will be 100, 2, and I finally got out to 800 there. All right, and that's my x-intercept, so that's where I've got a dot on 800. Okay, now my y was at 200, so I'm just going to go ahead and just keep it by hundreds. So I've got 100, 200, and since my y was at 200, okay. So now if I'm looking at this, solid or dotted line, so since there was an equal sign, we should have a solid line here. So I'm going to kind of zoom in and do a nice solid line best I can. Okay. All right, so now when it says, when I look at this, this says greater than or equal. So where would greater go? Well, greater goes up. Okay, so everything up on the high side here is going to get shaded. So go ahead and take a second, shade all that. Okay, all right, so now let's go ahead and put in our labels. We have not done that yet. So X, let's see, was yearbooks. So I've got yearbooks. My Y was class rings. So I'm going to put class rings. And I'll just put class picnic up here at top. Okay. All right. So then the last part to this is it asked to us in the directions to name a solution and interpret its meaning. So right here, name a solution and interpret its meaning. So remember, a solution is anything in the shaded region, and in this case, it could be on the line as well because it's solid. Now, I recommend when you're picking a point, just pick something that's not flirting with that line, just in case you pick a wrong number, it doesn't work. I recommend putting something just kind of like out here and kind of away from that line. So if I look at this coordinate point, right, my x value is 500. And my y value would be 300. So now let's think about what that would mean. What would 500, 300 mean? Well, 500 yearbooks, 300 class rings, and they're going to get their picnic. Okay, so let's go ahead and write about that down here. Okay, so my coordinate point was 500, 300. They can sell 500 yearbooks, because that's my x's, and 300 class rings to earn their picnic, earn the picnic. Okay, all right, and that concludes these notes.